3. So my question again, same thing. Let's draw the Lewis structure. So the Lewis structure, bromine and iodine, which one goes in the center? Well, iodine is a halogen. It is a terminal atom. It only wants one bond. It's not going to be in the middle. And bromine is one step from carbon. Carbon is usually a central bond or central atom. So boron goes in the middle. So boron goes in the middle. And then I'm going to distribute those 3 iodines equally around my central atom. Iodine, iodine, iodine. Let's figure out how many valence electrons I have. So boron has 3. Iodine has 7. There were 3 of them. So 21 is 24 electrons total. So let's begin by giving electrons to bonds. 2, 4, 6. And then let's fill the shells of the halogens next. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24. Did I count wrong? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Oh, haha, 24. All right, there we go. So 24 electrons. Let's check and see, do all of the halogens have full 8s? So iodine, 2, 4, 6, 8, yep. 2, 4, 6, 8, yes. 2, 4, 6, 8, yeah. Now let's look though at boron. Does boron have a full octet? 2, 4, 6, no, it doesn't. But the good news is boron doesn't care. So this is the correct electron configuration, or excuse me, the correct Lewis structure for boron. Note, boron does not need a full shell of 8. It was actually a +3. It was getting rid of 3, and it did. It gave them to the hydrogen, or to the iodines. All right, so let's look at its shape. I have three elements all bonded to this. They're all in one plane. And so I have, we try and visualize this, 1, 2, 3, all in one plane. Here we go. 1, 2, and 3. Boom. Central atom boron, 3 iodines around it, and it is all in one plane. So it is trigonal, triangle, trigonal, planar. So, all right, so let's look. So Lewis structure, then we said, what's the bond type? Bond type? Okay, well, Bi is a polar covalent bond. What is the shape? Let's do shape. Trigonal planar. Is it symmetrical? Ooh. Is it symmetrical? Why, yes, it is. Look at it. Doesn't matter how I put it. It looks the same. Yes, this is symmetrical. Symmetry? Yeah. Yepper, it does. Symmetry. Yes. And then, therefore, what is the substance type? Substance? Well, this is a non-polar covalent substance. So even though it is made of polar bonds, it behaves like a non-polar substance. All right, last one. Let's look at this last one. Let's have our compound B, BeBri. BeBri. So, which element should go in the middle? Well, let's look at our choices. Beryllium, Be. Beryllium, Be, plus 2 charge, 2 electrons to get rid of. Our other options are Br and I. Well, these are both halogens. They only make one bond, and so they are always terminal. They are not central atoms. So, ding, ding, ding. Beryllium is our central atom. So we're going to put beryllium here in the middle, and then I'm going to distribute bromine and iodine on either side. And we want to know the same things. I want to know Lewis structure. So A is Lewis structure. I want to know bond type. I want to know shape, symmetry, and substance. Okay, so let's come back up here to our Lewis structure. Let's figure out how many electrons we have to give away. Beryllium has 2, bromine has 7, and iodine has 7 as well, for a total of 16. 14 and 2 is 16. So start off in the central by adding 2 bonds, 1, 2, 3, 4, and then we're going to assign to the halogens next. 2, 4, 6, 8, 10, 12, 14, 16. There we go. Beryllium had 2 it wanted to get rid of. It did. Bromine wants 8. Iodine wants 8. Everybody is happy. So this is our Lewis structure. Our bond type, we have a beryllium iodine, and beryllium bromine. And beryllium is weird because it's actually acting like a nonmetal, and so we do say that these are polar covalent bonds. If we look at the shape, we see that these are equally distributed on either side. They appear to be linear. However, or excuse me, they are linear. So shape is linear. And then if we look for symmetry, it's bonded to 2 different elements. So if it's bonded to 2 different elements, there is no symmetry. So it has different poles for both of these, so I still say it's asymmetrical. So our substance type is going to be a polar covalent substance.